Alright, so happy Monday. Uh, Trying to get you guys some videos to help you out because some of you can use it. So this problem was from last week. I believe it's page 261, number 20. You will see it again on the test this Friday. Hint, hint, wink, wink, nudge, nudge, flashing neon lights in case you didn't pick up on that. You will see it again on the test on Friday. So uh, basically, we have two different boxes. Both of them have the same volume, so they have a different surface area. Obviously, they're going to save money by choosing box 2 instead of box 1. So first of all, what we need to do is find the surface area of both. So I'm going to show you a little trick to help you out when they set up the information like this. These boxes are rectangular prisms. Therefore, every face is some form of a parallelogram. How do you find the area of a parallelogram? It's just base times height. So we're going to do 20 times 6 because one of the sides is 20 times 6. That's 120. But then there's another identical face exactly opposite and parallel to it. So 120 times 2 makes 240. If what I just said doesn't make sense, you might want to draw a rectangular prism and then you'll get the picture. So then there's another side that's 20 by 4, that's 80, times 2 is 160. Last but not least, there's another side that's 6 by 4, that makes 24, times 2 is 48. So we add all of that up, 240 plus 160 plus 48, and box number 1 is 448 square inches. Now we'll look at box 2, we do the same thing, 15 times 4 is 60, times 2 is 120. Plus 15 times 8, that's 120, times 2 is 240, plus, last but not least, 4 times 8 is 32, times 2 is 64. So if we add up 120 plus 240 plus 64, we get 424 square inches. So obviously box 2 uses less material, but we want to know the difference between the two of them. So what we can do is to find the difference, we just subtract. So that's 24 square inches per box, but they're buying 50. They're going to save by choosing 50 of these. So we're going to take this, multiply by 50, and for 50 boxes and 24 square inches per box, that gives you a total savings of 1,200 square inches. So now we go back up to the problem and it says $1.25 per square foot. Well, this is square inches, that's square feet. Well, 1 square foot is basically 1 foot. It's a square that's 1 foot by 1 foot. Well, 1 foot is 12 inches and another foot is 12 inches. So this square that I've just drawn, 12 inches by 12 inches is really 1 foot by 1 foot. And 12 times 12 is 144 square inches. So 1 square foot is 144 square inches. So this, $1.25 per square foot, they could have also said whoops, let's undo that. They could have said $1.25 per 144 square inches. So what I suggest is a proportion. Yes, indeed, a proportion. I know it's been a while since you've heard that lovely word. So we could say $1.25 savings of 144 square inches. So that's how much? $1.25 per 144 square inches. That's the cost, not savings, excuse me. Well, if we are going to be saving 1,200 square inches, that's going to go down here. 1,200 square inches. How much does that save us? X. So our cross products, we do some cross products. We're going to do 1,200 times $1.25 and then divide by 144. We get a savings of approximately $10.42. So there you go. You might get a slightly different answer like we discussed in class if you changed all of these inches to feet right off the bat, or several other ways, but you're going to get somewhere around $10.50. There you go. Watch the video again and again and again till it makes sense. And if it still doesn't make sense, feel free to ask me a question. Peace.